about similar figures that way. So similar figures have to be, all the angles of a figure have to be the same, okay? And then all the sides have to be proportional. So like these two figures are not similar because the angles aren't all the same. So these are not similar even though they're both trapezoids, but these are similar. And like Johnny said, bottom right, similar, looks like, because the angles are the same. And the sides have to be proportional, so we have to look at proportionality, but there's a, we'll check on that in a minute. Whereas if you look at this example, we know right away, this is not similar.
But if the angles are all the same, doesn't it have to be proportional?
Yes. If the angles are the same in a triangle, it's going to have to be proportional, but we're going to look at the numbers in a minute, is what I meant to say. So this is a yes situation, and this is a no situation. So just before we start, you want to get an idea in your head. Does that make sense?
Yeah.
So I had a couple questions. Down here, how does this relate to ratio and proportion? Well, the corresponding angles may be equal. That doesn't. That's not going to be a ratio and proportion, but the corresponding sides being proportional is using the techniques that we did yesterday. So what's important is if you can find one contradiction to these two things, then you say the figures aren't similar. So for example here, once you can come up with angles not being the same, you don't have to look at sides being proportional. Does that make sense?
Yeah.
So here's a couple of examples. Over here, there's some notation. This little squiggle right here, that is, you read that as, is figure ABCD similar to figure PQRS? That means similar, that little squiggle. So you have to check to see if all the angles are equal, and they're all right angles, right? So you always check two things. So you say all angles are equal, check that off. And then you have to see if the sides are proportional. So this has a measure of 2 units and 4 units, right?
Mm-hmm.
And this has a measure of 4 units and 5 units. And you have to look at the letters. A has to be in the same position as P, because, so you always have to compare angle A to A, B to Q. What would you compare C to?
R.
R. So even if this whole figure was rotated, you would have to then rotate the letters. Does that make sense? They have to be in the same position. So raise your hand if you think they're similar. Not a lot of hands up. Okay, so you're saying no. No is the right answer, but you have to justify it. So how would you do it?
Well, because 2 is a multiple 2 is a multiple of 4. So those perpendicular sides are equal.
Right.
Well, they're proportional. But then like the top and bottom,
Yeah.
you'd have to multiply 4 by 2.
Okay, so one way is to look how to get from one to the other. Like the small short side is 2, and the big short side is 4. And if you want to get, so that's in this first figure here, right? But the small long side is 4, and the big long side is 5, right? Do you see that? So if these were proportional, this would have to be true. And 2/4 isn't the same as 4/5 because this is a half, right? And that's 0.8. So one quick way to show it is do something called the cross product. What's 2 times 5? 10. And 16, and those are not equal. So we say the sides are not proportional.
That's how you just.
That's how you justify it with a cross product or benchmark fractions. Scott, you can do either. benchmark fractions have to be equal, and they're not, or the cross product has to be equal. Raise your hand if that makes sense. Okay. We have time for one example here. It's on the board. I could write it down, but let's look at. I picked some examples. Let's look at this triangle. Let's look at this parallelogram one. I'm going to. So on this one, because they're oriented in a rotation, you want to imagine this parallelogram positioned the same, right? But you have to make sure that's what the letters say. Q and T should be lined up. So here's Q and T. Do you see how I rotated it? I put T here. Yeah, T, U, V.
No, you could have put V there.
T, U, V. Oh, right. That was supposed to be a V. Thank you. And W. And then this is 4.2, and this is 0.8. And over here, I don't know if you can see, this is 14, and this is 4. So you would say, is 14 to 4.2 the same as 4 to 0.8? Well, you would have to cross multiply and see. So 14 times 8/10
32.
is 11.2. And then 4 times 4.2, that's over 16, right? So they're not going to be equal. Does that make sense? So you guys are going to have to maybe read one example, but I think if you read an example, you'll be able to do this. It's easier than yesterday. Okay, so I'm going to keep going even though class ended. You guys left. I'm just going to finish up a couple examples. So we were doing 14 times 4 times 4.2, and what we had said before you left was this couldn't be the same because 4 times 4.2 is over 16. And so now that we know the sides are not proportional, we can say the figures aren't similar. I didn't even talk about the angles because in the picture it's showing the angles are the same, and really in your book it's going to even give you, it should have been giving you all the measures. So this would have been 60 degrees here, and this would have been 60 degrees here. So in this problem, since the angles were the same, that wasn't a contradiction. So I had to try to find another contradiction, and since I found out the cross product is not equal, that tells me the sides aren't proportional. And if the sides are not proportional, then the figures are not similar. Okay. On the next problem, I'm going to skip this bottom problem because we've done an example like that, but on this next page, the next thing you're going to be asked to do in your homework is find a missing length. And here, okay, here, this little symbol, remember, means similar. So in this problem, you're being told this figure, ABCD, is similar to this figure. When you're told the figures are similar, you can assume the sides are proportional. And so if you have to find a missing value, you just give it a variable and you set up a ratio proportion. So you would do the same thing. You would compare the big to the small, So you could say the big side to the small side in the first figure. So we'll make that the first figure here. Has to be in the same ratio as the big side to the small side in the second figure. And then you're just going to solve that ratio proportion. So you have x over 16 is equal to 15 over 12. So to solve that ratio proportion, you're going to cross multiply. 16 times 15 is equal to 12x. And to solve that, oops, sorry about that. To solve that, we have to divide both sides by 12. So this reduces, and remember here, you can practice simplifying. So 4 goes into 12 3 times, and 4 goes into 16 4 times. So this is the same as 4 times 15 divided by 3. That's what's going to give us x. And you could say 3 goes into itself 1 time, 3 goes into itself 5 times. So our final answer is 4 times 5, which is 20. So up here, we know this is 20 inches. Now, hopefully, on a problem, I guess on a problem like this, some of you would, multiply the 16 and the 15 out and then do long division with the 12. And that's okay, but I'm hoping that you're going to practice doing this reducing along the way here. You'll build your math skills. Okay, I'm going to scroll down a little farther to some problems that are also kind of like your book problems. Let's look at this one. And before we set this up, we have to read it. So this says, the extendable ramp shown below is used to move crates of fruit to loading docks of different heights. Okay, so when the horizontal distance, AB, that's this, is 8 meters, not sure if that 8 shows up so well, that's from here to here. The height of the loading dock is 4 meters. The question is, what is the height of the loading dock DE? So we want to know what X is. What you have to think about is, imagine that there's 2 triangles. So you have this triangle here, and pull that out of the picture, and we know that triangle has 4 meters to 8 meters, but there's also this entire big triangle here. So think of these as 2 separate triangles. And before we put side lengths on there, let's look. The angles are the same. So whenever the angles are the same in a triangle, we know the sides should be proportional. So that's always true for triangles. So the distance from here to here is the 8 plus the 12 meters, in case that doesn't show up on the computer. So that's 20 meters. So to find X, we're going to say 4 compares to 8. So the short side of one triangle to the long side of the same triangle, which is equal to X over 20. So again, if you think about this in a table, You can compare short side to long side. And this could be one figure. And this could be the second figure. This is the second figure. And this is the first. So you're going to set up ratio proportion, multiply, you get 4 times 20 is equal to 8 times x. Solve for x, divide by 8. And then practice doing reducing. 4 goes into itself once, it goes into 8 twice. So this is the same as 1 times 20 divided by 2, which is 10. So x, that's this distance here, is 10. The units are in meters. And the question is, what is the height of the loading dock? The dock would be like here. This would be like a ramp. You roll things up to get onto this dock. So the height of the loading dock is 10 meters. I think that's enough to get you started and through most of the homework. Look at the examples and come back with questions.